Data everywhere and no time to think. Well, this is the title of my talk. And you might be wondering what this actually means and why I've named this so weirdly. So hold on, we'll talk about that in just a couple of minutes. But firstly, who I am. My name is Aman Sharma, and I am currently co-founder and chief technology officer at Twimbit. Twimbit is a Singapore-based research company where we are using technology and digital innovations to create very interesting research that is very interactive and easy to consume. Also, I'm a member at deeplearning.ai. Plus, I love mentoring people. I'm a hardcore serial entrepreneur, and I don't define myself good in one special thing, but rather being a generalist in overall technology fields in web, cloud, ML, and AI. Also, you can find me on different mediums on this link. Well, currently the problem with you might be facing is that you have huge pool of data, huge ocean of data, and you are probably wondering that what you want to do with this data, or what actually is something called as insight from this data. You might be having a very good data science team and good data science tool, but figuring out what actually is a good insights that could change your business is very difficult. That brings us to a main question. What is the difference between data and insights? So let's try to answer that. Well, imagine you had a lighthouse source that could navigate you through important small pearls drifting in the oceans. These small pearls are your insights. These can help you make important data decisions, also help improve your business, or just improve your customer experience. And this source of light is today's presentation, which can help you get a little bit of idea what are the things you can do to improve the overall data science experience in your team. The agenda for this talk is divided into these sections. Firstly, we'll talk about some problems that has been occurring in the data science in these days and also some solutions on how to fix them. Then we'll go through a new method of data science and sprints that will help you understand a very new innovative way to plan your data science projects. Then we'll compare no code versus code approach towards data science. We'll also see how you should use visualization to deliver the message that you want to clearly deliver to the people using your data science. Plus, we'll also see a method of dashboarding that can bring in transparency and effectiveness of data science in the team. At last, we'll see documenting that will help you improve the overall data science research journey inside your team. Well, let's start with a couple of problems. The first problem that we have is called goal clarity problem. Now, goal clarity is generally when people in your team, probably more than 50%, don't have a clear idea of why actually your data science team exist, or what is the main goal of data science team at the end of the day. So often you are losing the track, your team is losing the track. People are asking questions like why we are here again, and are we just to complete what other seniors or manager level people are asking us to do. Then everybody in the team is having a different perception of how a particular project needs to be completed. This is leading to very wrong outcomes, like the managers are shouting at people, okay, this is not exactly what we thought of, and overall the data science team is not returning enough investment that they are actually consuming. Now, the solutions that you are saying here sounds pretty simple, right? Identify the goal and communicate that goal with the whole team. But Aman, how to actually identify the goal? So that's what we are going to talk about in a couple of slides later. The next problem that happens in any data science team is poor planning. Well, this is not the case only with data science team, but overall with any project. So the reason for poor planning is because of chaotic situation, and sometimes that also leads to abandonment of projects. This leads to a lot of wastage of time and resources for the team. Also, it leads to low energy results and like people losing the whole motivation and the persistence of completing the project. So you are often missing the deadlines and you are blaming the whole process for missing these deadlines. Also, the results that are yielding from all these data science projects are not good enough, and you are always wondering whether you have the right resources or maybe not appropriate resources to actually complete this project. The solution to this problem is also defined into these couple of bullet points. Firstly, you need to define a better project structure for the overall planning of the project. Also, you need to keep in mind that you will always have less and simplistic and realistic deliverables at the end of the project. If you create huge bullet points for the things to be delivered, then chances are that you will have more chances of missing the deadline. And also, always make sure that you have strict timelines. Having a discipline and strict timeline plan brings a very good structure in the whole team, and also gives a sense of completion at the end of the project, hence giving more chances of the team to celebrate the success, and then keeping the overall energy and motivation level. But how to do this, we'll also talk about this in our sprint method of solving the issues with data science. Another problem that people usually see is the dirty data problem, right? So you have data, but it's either bad, or the vastness of data is such that you are not able to classify what data you should use and what data not. So you are probably spending too much time on the data processing than the actual insights. Also, the ratio between the data that you are inputting inside the project and the insights that you are able to gain from the project is not equal, probably in the ratio of 90 is to 10, where 90 is the input of the data and 10 is the insights you are able to get from the data. This leads to a very very poor results format, and you are probably guess again not able to hit the goal. This can also be solved by using latest technology in data science for data pre-processing and data sorting and even data collection. And also you should be able to improve the ingestion of these data from whatever source you are getting the data. There are probably many tools and robotic tools that can help you improve the ingestion of these data. We'll talk about these tools also in the couple of slides later. Another problem that the team has is technical challenges, which are mainly classified into limitation of tools, limitation of resources, limitation of talent, and sometimes also privacy concerns, which have been rising these days too much. Well, privacy is something that protects people, but also it makes the job of data science engineers very difficult when you cannot explicitly use the direct information and personal data of users. Hence, you need to be very careful and decisive on which data you should use and what data you shouldn't be using, and be respectful of. Well, this probably the symptoms for these challenges are that you are always wondering that you have less people in the team. Also, the turnaround time for any project that is going on is often divided in months and maybe more than months, and it should be probably in weeks, but you are not able to complete those things on time. The system of your whole team for delivering data science project is probably not that efficient, and every time you are losing the deadlines. Also, there is a lack of transparency between the technical staff and non-technical staff, hence you are not able to predict whether what you are doing is right or wrong, because the people that are actually using the data science, the outcome of data science, are not much aware about what is actually going inside the technical team. So the one is pretty simple: bring the transparency, right? But how you should do it, that's also what we are going to talk about in the documentation process. Documentation is a very neat process where we can share what the project progress we are making with everyone in the team, hence bringing a lot of transparency and understandability between teams of technical and non-technical background. Also, giving tools such as no code can reduce the overall turnaround time and also the limitation of resources that a team generally possesses. Another problem is the complexity of the whole system, in which the data science is usually limited to only technical people of the team, and hence not the non-technical people are able to 100% utilize the whole data. This insufficiency of data is actually leading to not a very good method of representation of information, hence making the information ununderstandable. Well, the symptoms for this problems again are that people are complaining that they are not able to read the data. Also, the decisions that are coming out of these data are not that efficient. And sometimes you might even think, let's skip the data science part at all in the team, and why we need to have data science team at the first place. Then solutions to these problems also include bringing the data science capability to the non-technical team using the power of no code. Also creating better visualization and delivery techniques for the whole data science so that it's very easy to understand the data and directly interact with it. Also taking regular feedback from non-technical people and everybody in the team, even sometimes the outsider, to understand whether the whole team is doing good with the data science project or not. Now, the last problem, the biggest one, is silos. Well, if you know about the word silo, it probably means when you keep things separate. Well, I have seen people having this problem. Even in my team in the beginning, we were having so much silos between the data science and the outside world team. Well, these silos are mainly developed when people don't want to, totally clarify what they are actually working on. Then people start questioning the intent of what actually is going on into the project. And hence, when these two teams don't communicate, it creates silos. And the main symptoms for these silos are that there is no interdepartment communication, not even between marketing and sales team, or maybe engineering team or product team. Well, sometimes these two are same, but you get the intent, right? Well, if team won't communicate and won't see the data in real time, then they won't be able to make collective decisions, right? And that leads to a very lower growth of the overall team. And the growth part is very important in any company, especially startups. I work in a startup right now, and we know that how much important is to make effective decision to grow your company at a very good speed. And then again, using our last symptom, that everybody start feeling the importance of data science inside the team less than what actually they intended for. Solutions for this kind of problem also includes dashboarding, which is a method of representing and keeping the data reports transparent with everybody. Also adding a touch of automations where things happens without much of human effort and for everyone. Again, taking care of feedback from people and implementing those feedbacks, and also documenting the whole progress of the project well, which is shared again with everyone. Now, these were the problems, and the sprint part that I was talking about that can help you solve the problem. Well, this is the section where we talk about it. So, the whole sprint, if you don't know about what actually sprint means, sprint is basically a sprint in an actual way where you dedicate the whole journey in, the whole run into a very smaller period of time, where the main goal is to complete things as soon as possible. Well, you might think that, Aman, why actually doing things fast is a solution to a problem. Well, this is little different. A sprint is a very structured way of moving fast, just like how Usain Bolt would plan a 100-meter sprint, where he will try to conserve his energy and make it equally distributed over the course of the whole marathon, or maybe the sprint race of 100-meter, right? In the same manner, the sprint process, which you have experienced in software development, is also very applicable in data science. The whole the process is divided into four main steps. The first one is to actually clear the goal, so that everybody is on the same page. The second one is to plan well for the project, again to bring more clarity and more transparency about what's actually going to happen inside the project. Then the third step is actual execution, and then the fourth step is testing the whole results and improvising over it. Let's start with the first section. The first thing that you should do in any data science project is to introduce everybody with the goal of the whole agenda. What you need to do is to set up a long term goal, a long term objective that you wish to solve. This can be, let's say, return the overall ROI of the landing page, or maybe increasing the overall clicks that takes for a person to add products to the cart. Anything that is the whole motive of running a data science project. And this should be done in a democratic fashion by collectively asking everybody, what actually we are trying to do here. And if somebody isn't having any goal clarity, then you should talk about it. Then you should set some sprint questions. These are a little bit of more granular goals. Like for example, if you are trying to reduce the number of clicks for the checkout process, then the sprint questions that you might be asking can be such as, what is the time that a person takes to make the whole process happen? What percentage of people abandoned the whole checkout process at, let's say, step 4? So these are the actual questions that you want to set before starting the data science project, and you should match if you were able to answer these questions at the end of the sprint or not. Then you should try to also create a map of the whole journey of data science, a very easy to make flow chart which defines, okay, if step 1 happens, then you move to step 2, or if the result of step 2 is this, then we'll do this, or the step 2 will go in here, or something like that. You get the idea about the map, right? So basically, to bring clarity about the goal again into a very diagrammatic fashion. Well, once the goal is clear and you know what you are actually trying to do, you should start planning about the project. The first step to plan a project is to talk with experts. These experts can be your mentors, people from outside, and even some couple of existing documents that people have done in a similar fashion, which are trying to solve the same kind of problem that you are doing. Well, this will help you create some notes that are going to be very helpful in the next steps. Then you should pick a target. Well, because we discovered and discussed before that effectively to plan well and do things properly, you should have less deliverables. Well, that is this step where you decide actually what are the things that you are going to do today. You cannot the Rome was not built in one day. I'll again use the same proverb. Well, that is very applicable in data science too. You should be very much choosy about what you should solve first. You cannot do the whole answers to all questions in just one day. So pick up the priorities, pick up the first, second, and third priority for your project, and then move decisively into a much more granular way, so that you have a very clear goals and very good sense of achievement when you complete one target. Then, if you have a team of 3 or 4 people, ask everybody what their wild guesses or maybe the research that they are doing, what to them look likes that this problem can be solved with. So this will call how might we notes, in which everybody gives some pretty good ideas about how they think the problem can be solved or this process can be done. You should organize these notes and then vote democratically over these notes. You can choose to do it with stickies. Multiple people can vote for multiple notes, and then finally whichever has the best notes, you should pick that approach. Those one that are not considered right now should also be kept for future sprints. Then pick an approach. The pick approach actually means what tools you are going to pick, what technique, whether it's code or no code, that you are going to go with. So this is what we'll do in the fourth step in plan well section. Then finally create a flowchart diagram of the whole data science project. Well, this is actually the software UML kind of diagram that you will try to create. Again, the main goal of creating a diagram is to bring clarity in the team. Then finally, when you have planned well, you will move toward the step 3, that is execution of the whole project. Firstly, set the deliverables. Again, from your pick target section, set deliverables in terms of technical language, like creating this dashboard or creating this ETL or this pipeline. So this should be your step 1. Then create a timeline of things when you expect things to happen. Having a timeline keeps the whole team in track and doesn't lets you miss the deadline. Divide the task appropriately with the whole team, and divide in such a way that everybody has a shared responsibility. Even if a person is not contributing directly towards that task, having a sense of responsibility brings more attention towards things if they don't get done on time. Then also meet regularly. Have a weekly calendar or monthly calendar when you decide, okay, this is the date when we'll pick and discuss everything again about the goal, how we are doing things, so that everybody stays on the same track. Then when you are done with the whole project, create a small MVP or the test report of the whole finding and share it with the team that actually is going to utilize these findings. Present these findings in a very good effective format without explaining them much about the project. Remember, you are looking for actual hard feedbacks without letting them get feared about non-technicalness or their inability of understanding the thing. If they are not unable to understand the reports, then it's not wrong with them, it's actually wrong with your reports that they are not so easy to understand. So collect these feedbacks and then improvise over them. Also, you should document these learnings about these feedbacks and try to implement them again when you are trying to come up with the second sprint, so that you don't make the same mistakes again. Well, this sprint was actually inspired by a book by Jake Knapp called as Sprint, in which he talks about how to test ideas in just 5 days. So I totally recommend to try it out and read and see yourself how you can apply these things in many other different projects also. Well, we have talked a lot about diagrams, and diagrams is a very important thing to make everybody clear about the goals and the plan of the project. It also helps you achieve realistic goals and set actual realistic timelines. It also helps you in estimating resources also. So let's see a small example of how you should actually create the diagram. The step to create a diagram that I have always been fascinated about is divided into these four steps. The first step is actually creating the main kind of blocks of the whole project. These can be maybe a form. Then well, you are not trying to create the connections right away. You are trying to create the actual blocks that are the main building blocks of the whole app. And this can be, for example, the ingestion system, the dashboard at the end, or maybe a automation system in between, data preprocessor, and other stuff like that. This totally depends again about the type of data science project you are doing. Then start creating diagrams that could help understand the relation between these steps. For example, ingestion should be connected with the data pre-processing part. Then data pre-processing should leads to data curation part or whatever it's over there, and then it should finally do a dashboard. And the whole process should be connected via automation with this automation tool that you are using. See how easy it is to. Firstly, we created the blocks, then we labeled the blocks of what resources we'll need. Then we connected these blocks with estimatedly, inputs and outputs, that how things are moving. Well, the common tools that I used for diagramming are, for example, Miro, which I made the current presentation with. Also, you can use diagrams.net, which is a very easy way to create diagrams. The main goal again is, remember, to bring clarity in the project. You are not trying to build a NASA level rocket engineering diagram, it's just to bring the clarity. Okay, so the diagramming part is done. The next part is choosing an approach. Well, the approach that I see in modern world is divided into two main things. One is code and the another one is no code or low code. There are pros and cons to both of these approaches. Let's go over them. So the code one is relatively flexible, in which you have the freedom to do anything that you want, as far as you know the technicalities and you have appropriate knowledge about the code you are writing. It's pretty scalable too, because you can do pretty much everything and scale it to n number of machines or servers, let's say. Also, the function availability, the flexibility it gives to do many different things is very high. The cons to these approaches are, well, you need to know the programming language at the first place, so of course the technical proficiency can be a very big bottleneck. Also, the lack of talent, how you will bring good data science into the team. This lets you stagnate and wait the whole data science project for a very while until you have a good data science person in the team, right? Also, because it's code, that means very less team people will be actually doing this, so there are probably silos in the team. And also, sometimes the complexity of the whole model, if it's a machine learning based data science project, or maybe even the raw data that's so complex in the code system that you are not able to directly see through or plan through the project. Well, some of these problems are fixed with our no code and low code approach. Firstly, the most amazing thing about no code low code is the speed, the lower turnaround time, which lets you see the final result very very earlier than a code technique. Also, the learning curve involved in learning these tools is pretty much very easy. Maybe a couple of YouTube videos and you can yourself see yourself using that tool very easily. Also, because these no code are meant for very non-technical people, hence it's very fun and engaging to use these tools. This also increases the productivity because you are spending very less time in doing jobs that are not important, like data pre-processing or cleaning of data, because a no code low code tool will do it itself. And also the openness of these tools, anybody in the team can actually learn to use the software and create their own no code data science project. Well, the cons are the flexibility. You are only limited to the options that the project is providing you. Also, the sources from which you can collect the data is very limited to the options that this no code low code tools can actually ingest. Also, some people have complained that they create a dependency on that no code tool, that maybe in the future it's not that much expensive or affordable anymore to use that no code tool, and hence you are kind of vendor logged in and stuck with that no code approach forever. And also scalability issues, it's not as scalable as code, because again you are limited to the features and the scalability capabilities that that application provides. Well, after seeing this approach, let's see what are the common code tools that people use these days. Well, the first section is probably the one that you already know about. That is data science programming languages. Today, this one is actually a Python level conference, so you probably know already about Python. And R is also a very competitive and good programming language, having lot of inbuilt functions for data science freaks. And Scala is also a very well growing language for data science projects. Then the other category is for querying and analysis. Again, you have structured query language. Also, I haven't included over here, SQL and NoSQL are both kind of a good querying language and analysis tools. Then you have MATLAB, which is more used for statistical analysis, or maybe real world physics level kind of data science project that you would like to do. Also, BigQuery is a big data based data science querying language, which is made on Google data servers, Google cloud, I'm sorry. And it's also a very good and very easy to use tool if you want to just get into the beginning of querying and analysis. Then you have another category, which is collection of the whole tools at all. It's actually a whole suite of different tools and technologies inbuilt. For example, Apache Spark, which is collection of dashboards, tools, ingestion models, and various number of tools that usually you have to bootstrap yourself, but in Apache Spark everything comes built in pre-packaged. The same is the case with BigML and Hadoop. Well, I haven't personally used Hadoop, but I have seen people very fond of Hadoop, which is a very good tool for big data and have out of the box solution for big data problems. Now let's look at the other category of tools, that is no code or low code. The first one that I always love is Google Data Studio. Google Data Studio is a free to use tool where you can create dashboards and reports with a very easy drag and drop method. It has very good data sources which you can ingest. You can also import your own data inside Google Data Studio to create these dashboards. Tableau and Power BI are also similar to that. Well, I haven't used them, but people have given their feedback that these are also amazing tools to use. Then other no-code tools also include tools to easily build and automate the whole data science flow with a very easy drag and drop kind of fashion. For example, Xplenty and Intersect Labs are the one in which you can create the whole pipeline with just using couple of if-else rules and options without even knowing what's actually going into the backend. Data Robot is also a similar tool in which you can create your own ETL and pipelines to create effective data science workflows. Then there are tools like obviously AI and Gyana that are same end-to-end suite like code techniques, but here everything is very much visible and clear for even non-technical people, and they can start using the end-to-end capability of data science without even knowing a lot about programming languages. Well, you might be confused that how you should actually choose this technique. The answer is simply divided into these metrics. For example, if you can see on the left side, we have divided this into functional requirements, and on the top side you can see it has been divided into the speed of implementation. So if your functional requirements are low and the speed that you need is pretty much slow, you don't need that in pretty much fast time, then this is perfectly suited for no code AI solutions. Pretty much good to start with individual projects if you don't have a good big data science team. Then on the other hand, if you have low functional requirements but the speed needed is fast, then it's also suited for AI, no code AI tools. Well, you need to have a couple of people inside the team to do this. But if your requirements have high function availability, then probably you need to switch between code techniques all the time, even if the functional requirements and the speed required is slow or fast. The slow one is good for individuals who wants to just start with data science and then implement data science, but the in the fast one you need to have high capability of coding language and all that. So I hope you will be able to make a decision out of whether you want to go with code techniques or no code techniques from this matrix. Now let's get into visualization. Visualizations is a very important thing, like a kind of a language to understand data. And I found this very good diagram by active wizards that actually talk about how you should choose what kind of charts you should use for what kind of data. For example, if you have one variable, you can go with this technique, this path, sorry, maybe this path, yeah. And if you have hierarchy, then you can go with this path. Again, I'll leave this diagram to you to explore, but you get the idea. You just choose what questions you have about that variable and what kind of data you want to represent, and choose the appropriate diagram according to that data. Well, this is like mastered and like kind of understood by people, so I won't actually go into the deep understanding or mathematics behind this thing. There is another very cool diagram about different nuts and bolts of different chart types, like what histogram is about, what bubble chart is about, so that you actually understand what these charts actually do without just dragging down because that's why they look fancy, or just choosing the color based on your favorite color palette preferences, but actually having a science behind backed for these charts that you are using. This brings us to pretty much almost the end of the presentation. I told you that dashboarding is an important process which helps you share your findings and works with everyone. The step to dashboarding is actually divided into 4 steps that I have showed over here. The first step is actually collect all the visualization that you have just created after deciding that what kind of charts you are going to use, then organizing them in a fashion so that things are pretty much visible and very kind of cool looking, just like a Tony Stark movie, how he uses charts, right? I mean, you get the idea that you want to simply lay out everything so that everybody is visible and collectively functional with each other. Then you should also set up automation or a scheduler which tells you and reminds you again and again to visit this particular dashboard and again improve the decision making process. Then in the final step, share this access with everybody inside the team and have a system to collect feedback regularly from this team. That is the main goal of dashboarding, guys. To understand what are the different tools involved, I have listed down the tools such as Apache Superset, Airflow for creating DAGs and automations. Gramex is an end-to-end tool which is still in early phases, but it's a very effective tool to create dashboards. Plotly Dash again is a very good tool to create dashboards, and Amazon Quick Sites to create dashboards again. So you can visit yourself and see which tools works perfect for you. Then documenting. Well, we told you that documenting is a very good way to actually learn from the feedbacks and improvise it even in the coming steps. The process of documentation is divided into again 4 steps. The first one is to create a shared document. This shared document can be a Excel file or a Trello board or even a Monday.com or Airtable board, which I love, by the way. Monday.com is like the charm of creating data science project or documenting actually them. Then you should actually monitor the progress of the whole process, which should be visible to everybody in the team so that they can see how the data science team is doing. And then whatever findings you are getting, add to this board, this dashboard that you have just created, and then collect feedback so that you have a well created repository of these tools. Well, again, I have already talked about what tools you can use. You can simply use even Google Sheets to create the document for the whole data science project. As far as you have a single document to come back again and see the feedbacks and the learnings from it, that's what matters with the documenting process. Well, that's pretty much about it. We have talked about almost a lot of things, starting from problems, sprint technique, different approaches, diagrams, and all that. Well, that's a lot of things to do, right? Well, let me short and specify them into a very summarized fashion. So firstly, we talked about the problems, that what are the problems that are causing today's data science issues. Then we also saw a couple of solutions which led us to a technique called a sprint. We also learned about how to create short diagrams, and then also we learned about the code and no code approaches to data science.